Hi everybody, back with lesson 20 homework. This is page 171 and we're going to be using tape diagrams to help us solve our problems. The tape diagram helps you understand what picture it, what it means. It doesn't solve the problem, but it tells you how to solve the problem. We are looking for the whole and the parts. So in this first one, Luann has a piece of ribbon that is 1 yard long. She cuts off 33 inches to tie a gift box. How many inches of ribbon are not used? Well, we're talking about a yard here and then inches. So we need to know all of this. 12 inches equals 1 foot. 3 feet equals 1 yard. So how many inches are in a yard? There's 12 inches in each of those feet. So we have 36 inches in 1 yard. So she has a piece of ribbon that is 1 yard long, and then we're talking about inches. We need to make sure the whole thing is in inches. We can draw this first part. Luann has a piece of ribbon that is 1 yard long. But again, I want to say in inches. So I am going to say that this hole is 36 inches. She cuts off 33 inches to tie a gift box. So that's a part that I know. 33 inches she cut off for her gift box. How many inches of ribbon are not used? That's the part over here. We don't know what this is. We know this, and we know the whole thing. We need to find out this part. How much is left? How much is not used? We are missing one part. If we have the whole and we are missing a part, then we are either subtracting 36 minus 33 equals something, or we are counting up from 33 plus something to 36. We can do it either way. So if we were to subtract, we can use the standard algorithm, 36 minus 33. That's a pretty simple problem, isn't it? 6 minus 3 is 3. 3 minus 3 is 0. So how much is left over here? 3 inches. So how many inches of ribbon are not used? 3 inches. And again, I'm just going to use the words that are in the question. 3 inches of ribbon are not used. So we are looking for part, whole. We've been using part, whole one way or another all year. That's what the tape diagram helps us figure out. What's the whole? What are the parts? But then we need to use some of those strategies that we've used all year. The arrow way, the standard algorithm. If you need to, if it makes you more comfortable, do a chip model. But we are either subtracting the part from the whole, or we are adding up from a whole to get up from a part to get to the whole. Either way. So let's look at the next one. Elijah runs 68 yards in a 100-yard race. How many more yards does he have to run? Let's look at what we can draw. Elijah runs 68 yards in a 100-yard race. What is the whole? We have two numbers here to work with. What's the whole? 100. The whole race is going to be 100 yards. So I'm going to draw my tape diagram. And I'm going to say that that is 100. Now, do I need to change it? No, because both of my numbers are in yards. So they are both in the same unit of measure. So the whole race is 100 yards. How far has Elijah run? Elijah has run 68 yards. That's this part over here. We need to know how many more does he have to run. We are missing this part. So it's the whole minus a part to equal the other part, or a part plus something equals the whole. Last time we did the standard algorithm to subtract. This time, why don't we count up the arrow way? So we are going to do 68 plus something to get to 100. I'm starting with 68. As always, I'd like to get to the next 10 because it's easier to count. So I have an 8 in the ones place. What do I need to add to get to my next 10? I'm going to add 2. If I add 2 to 68, that takes me to the next 10, which is 70. And now I need to get to 100. If I know 7 tens plus something equals 10 tens, 70 plus something equals 100, great, I can use that. If I'm not sure, I can just go up 10 at a time until I get there. So I'm going to add 10. And 70 and another 10 is 80. Still not there, so I'm going to add 10. 80 plus 10 is 90. Still not there, I'm going to add 10. 90 plus 10 is 100. Now I'm there. In order to find out what this missing part is, I need to add together these numbers because I added all this to 68 to get to 100. So I have 10 and 10 and 10. 10, 20, 30. Plus 2 is 32. Now you might have said that you knew 7 tens plus 3 tens is 100. And so you might have just added 30 on that arrow right there. But if you're not sure, break it down. Do 10 at a time until you get there. So all we have left is our statement. How many more yards does he need to run? What is our missing part? 32. He needs to run 32 more yards. Cool. Chris has a 57-inch piece of string and another piece that is 15 inches longer than the first. What is the total length of both strings? Okay, there's some missing information. They're asking me to find the total, but I don't know how long both strings are. Let's go back and see what we can draw. Chris has a 57-inch piece of string. I can draw that. Now, is this the longer piece or the shorter piece? He has a 57-inch piece of string and another piece that is longer. So this 57 is the shorter of the two pieces of string. So I am going to draw that piece of string and I'm going to label it 57. Now the longer piece of string, I don't know how long it is, but I do know that it is longer than this one. So I'm going to try to start them at about the same place so I can see. I'm going to make it longer. And I don't know how much it is all together, but I do know that this part, how much longer it is, this is 15 inches. I don't know how long the whole piece of string is. Okay. Looking at this, what is the total length of both strings? Eventually, I have to add these together and get the total. So I want to make sure that I understand that I need to find this and this. So let's move on. Which number is the whole? The whole is the part we don't know. What do you do if you have two parts and you don't know what the whole is? You add 57 plus 15 equals blank. So we need to find the whole, putting the two parts together. What's the whole thing? So I need to add these two numbers together. I can do that in the standard algorithm. I can use it totals below. I can do a chip model. I can do the arrow way if I want to. So I am going to do the chip model. The chip model, remember, is very useful, so don't forget about it. I have my hundreds, my tens, and my ones. I'm going to show 57. 1, 2, 3, 4, 5, 7 ones. And I'm going to add 15. So that's 1 10 and 5 ones. Does it look like I can make a 10? It does. I have 5 up here and 5 down here, so that's 10, and then there's just going to be 2 left, so I'm going to leave 2 up there. And I'm going to bundle up that 10 ones and bring it over to make another group of 10 underneath. How many ones are left? 2 ones. Adding up my 10s, I have 5 plus 1 plus another 1. That's 7. So when I add 57 and 15 together, I got 72. That is how much my longer string is. I still have to solve this one. I don't know how much this one is. I need to add together the 2 strings. What is the total length of both strings? So I need to add together which 2 numbers? How much is the shorter string? 57 inches. How much is the longer string? 72 inches. So again, I can use a chip model. I could do the arrow way. I could do totals below. Lots of different ways to add. I'm going to say, I'm going to do totals below. So 57 plus 72. 7 plus 2 is 9. 5 tens or 50 and 7 tens or 70 is 12 tens, which is 120. So that's 9, 2 plus nothing, 1 plus nothing, 129. That's this. Whoopsie. 100, no eraser. 129. That's my total. So all I have to do now is write my statement. And again, I'm going to use the words in their question, What is the total length of both strings? The total length is 129, and we are talking about inches here. Ooh, I almost ran out of room. The total length is 129 inches. That was a lot of work on one question. I'm going to turn the page. So on page 172 now, Janine knitted 12 inches of a scarf on Friday and 36 inches on Saturday. She wants the scarf to be 72 inches long. How many more inches does she need to knit? Sounds like we have more than two parts. Janine knitted 12 inches of a scarf on Friday, 36 inches on Saturday. So that's two parts right there. Do we know how long the whole scarf is going to be? Do we know our whole? We do. It's 72. The whole thing is going to be 72 inches. Now, we have two parts and another missing part. So I'm going to write 12 inches for my first part. I'm going to write 36 inches for my second part. And now here is how much more we need to get to 72. How am I going to find that missing part? When we're missing a part, we usually subtract. The whole minus one part equals the other part. But we have two parts already. We should start by adding these two together. We have a three-way number bond. We have 12, 36, and another mystery. We need to subtract this from 72, so it's going to be easier if this is one number. So we're going to have 36 plus 12. 2 and 6 in the ones place. 8. 3 tens plus 1 10. 4 tens. So altogether, this part is 48. Now we can subtract. We're going to have 72 minus 48 equals blank, or 48 plus something equals 72. Those are our equations every time for a missing part. The whole minus the part, or the part plus a mystery part equals the whole. Up to you if you would like to subtract using the standard algorithm. I think it's going to be easier to go up in the arrow way. I want to get from 48, I want to get to the next 10 because it's so much easier to count up when I've got a 10. So I'm going to start by adding 2. That'll take me to 50. Now, do you know how many more 10s we need to get to 70? We have 50. 10 more would be 60. Another 10 would be 70. So we need 2 10s, and I can do that in one step if I want to. If you can't, do it 10 at a time until you get to 70, and then you can add those together. Now this is going to take me to 70, and that's not where I'm going. I need to add what still to get to 72? I'm going to add 2 more. And now I just need to add these up. This is what I added to 48 to get to 72. So I have 2 plus 20 plus 2. 2 and 2 is 4. 20 plus 4 is 24. So the missing part is 24. How many more inches does she need to knit? She needs to knit 24 more inches. All right, hang in there. I know this is a lot of work. We're almost done. Let's look at number 5. The total length of 3 sides of a triangle is 120. The 2 sides of the triangle are the same length. One of those equal sides is 50 feet. What is the length of the side that is not equal? Okay, we've got a 3-parter again. How much is the whole triangle? The total length of 3 sides is 120 feet. That's my whole. 120. And we're talking about feet this time. So the whole thing is 120. 2 sides of the triangle are the same length, and one of those equal sides measures 50. This is the part we're trying to figure out over here. These 2 sides are the same, and this one is 50. So what's this one? It's also 50. So we've got 50 and 50 and something we don't know. So again, we would need to subtract our parts from the whole to get the missing part. It's going to be easiest if we put these two together. Luckily, that's pretty simple. What is 50 and 50? That's already 100. Now, the equation would be 120 minus 100 equals blank, or 100 plus something equals 120. But I bet you can do that in your head. How much more do you need to add to 100 to have 120? 20. So the unequal side is 20 what? Feet. Always include the unit. Don't leave that out. Last one. The length of one side of a square is 3 yards. What is the combined length of all 4 sides of the square? So I'm going to just draw my square over here. It's difficult to draw a perfect square because all the sides have to be the same. So this is 3 yards. So what is this? All sides are the same. This one is 3 yards. This one is 3 yards. So this one is 3 yards. And this one is 3 yards. So what is the combined length of all 4 sides? We have 3 plus 3 plus 3 plus 3. Do you remember when we were doing our arrays? If you don't remember, 3 plus 3 plus 3 plus 3 equals 12, and this is yards. So what is the combined length of all 4 sides of the square? The combined length is 12 yards. They finished up with some easier ones than we started with, didn't they? I know that's hard work. Thank you for trying. See you next time.